Hey everybody, in this video we're going to practice finding limits algebraically. If you want to follow along, the links to the companion worksheet are in the description below. So, let's get started. We already saw how to find limits numerically in the previous video. Now we're going to look at finding limits algebraically so that we don't have to keep plugging in a whole lot of numbers. Now the easiest way to find limits is to find what the variable is approaching and just substitute it in. So in this case, we're saying that y is approaching 0. So the easiest way to find the limit is to substitute and see, well, what is y at 0? And let's see, well, this is a function that is continuous. It has no breaks in it. So it's also going to approach that. So if I plug in 0 in for y here, and 0 in for y here, we get -1. That is what our limit is equal to. So as y approaches 2, 3y squared minus 2y, or plus 2y, minus 1, approaches -1. And that's always going to be the easiest way to find a limit. Looking down here at number 2, we want to see, well, what is 7 as x approaches 2? Well, there is no x in this. 7 just remains 7. And so since there's nothing to plug in, the limit is just 7. These two tend to be they don't happen very often when you do limits algebraically, but I wanted to show them to you because oftentimes when people get to some of the later problems, when you start to simplify things algebraically, they look at these problems and they forget how to do them. These are actually the easy ones right here. So let's go down to number 3. So here we have x is approaching 2, and the function is 4 minus x squared over x minus 2. Now look what would happen if we were to substitute in 2. We would have 4 minus 2 squared over 2 minus 2. We would end up with 0 over 0, which is undefined. That doesn't mean that the limit doesn't exist. What that simply means is at 2 there is no value, but just because that value doesn't exist doesn't mean the function isn't approaching something. So what we do is we look at this expression and we ask, how can we simplify it algebraically? Well, the top is a quadratic that we can factor. We can factor the top into 2 minus x times 2 plus x. And the bottom, we still have x minus 2. Now, these two terms are related, but they're not identical because these two are opposites. So what I'm going to do is I'm going to factor a -1 out of this. And when we do, we're left with x minus 2. We still have 2 plus x, and we have x minus 2. So now that we have these two identical factors, now we can cancel them. And so now we're left with -1 times 2 plus x. Now why did we do that? Well, we couldn't plug in 2 into this expression. It gave us an undefined value. But what would happen if we were to plug in 2 into this? -1 times 2 plus 2 equals -4. That's not undefined, and that's our answer right there. So I'll write it over here off to the side. The limit as x approaches 2, 4 minus x squared over x minus 2, that's equal to -4. And so what we're looking for is, how can we algebraically simplify this so that we can plug in the value we want? So looking up here at number 4, if we were to plug in 3 cubed is 27, minus 27 would be 0. Plugging in 3 here, minus 3 would be 0. So again, we would have 0 over 0. And that's going to be true for all the rest of the problems here that we go over. So we need to ask, how can we simplify that? Now in the previous problem, the numerator had to a difference of squares. Here we have a difference of cubes. So how does that factor? Well, it's going to factor into x minus 3 times x squared plus 3x plus 9. If you need a little review of difference of cubes, you can go look that up as to how I came up with that. But having done that, we have x minus 3 in the top and in the bottom, which means we can cancel them away. And what that leaves us with is x squared plus 3x plus 9. So if we substitute in 3, we have 3 squared plus 3 times 3 plus 9. So that's 9 plus 9 plus 9. So that's 9 3 times, so that's 27. So that is what our limit equals. The limit as x approaches 3 of x cubed minus 27 all over x minus 3, that equals 27. So now, let's look at number 5. With number 5, a is approaching 1/2. If we plug in 1/2 into the top, 2 times a half is 1, minus 1 is 0. 1/2 squared is 1/4, times negative 4 is negative 1. If you add 1, you get a 0 again. So we can't just plug in 1/2. How can we simplify this? Well, the bottom is a quadratic, and we can factor that. So on the top we have 2a minus 1. On the bottom, this is a difference of squares. So this is going to be 1 minus 2a and 1 plus 2a. Now, we're going to look to cancel some things out. Here we have 2a minus 1. Here we have 1 minus 2a. They're similar, but they're opposite. So to make this work, we're going to have to factor a negative 1 out of this 1 minus 2a. So negative 1, and then in parentheses 2a minus 1, and then we still have 1 plus 2a. That's not changed. Now that they're the same, now we can cancel them. We can only cancel when they're identical. So on the bottom, we're left with negative 1 and 1 plus 2a. A lot of people are a little confused sometimes about what's left on the top. Is it 0? No, it's 1. And that's because anything is multiplied by 1 at all times. So that's why it's 1. At this point, now we can plug in 1/2. So 1 over negative 1 times 1 plus 2 times 1/2. So we have 1 over negative 1 times 1/2 times 2 is 1, plus 1 is 2. So we end up with a value of negative 1/2. And that is what our limit is. So over here, if we write limit as a approaches 1/2, we have 2a minus 1 over 1 minus 4a squared, and that limit equals negative 1/2. Okay. So for number 6, here we have another set of polynomials, one on top, one on bottom. Now, in the previous ones, we had one quadratic and one linear, and it seemed pretty obvious that we had to factor out the linear factor with one of the terms of the quadratic. But here we can't see what's going to be factored until we actually go ahead and factor this. So x squared plus 5x plus 6, so that's going to factor into x plus 2 times x plus 3. And then on bottom, 2x squared plus 11x plus 15. That's a little bit trickier because we have a 2 in front of the x squared. So that's going to be 2x and x. And 15, that's going to break into 5 and 3. So that's going to be 2x plus 5 right there, and x plus 3, like that. So that's how this factors. And as you can see, well, what do we have? We have x plus 3 on the top and on the bottom, and they're identical. So at this point, we can go ahead and cancel that. leaving us two linear terms, x plus 2 on the top and 2x plus 5 on the bottom. So now we can substitute in 3 in for x. So 3 plus 2, 2 times 3 plus 5. So 3 plus 2 is 5. 2 times 3 is 6, plus 5 is 11. And so that is our limit. So the limit as x approaches 3, x squared plus 5x plus 6 over 2x squared plus 11x plus 15. That's going to equal 5 over 11. So in all these cases, we had a polynomial, or 2, where we had to factor and cancel out the common factor. Number 7 works in a very similar way, except here we have to expand this out, not factor it. So we have 5 plus h quantity squared. So that's going to be 25 plus 10h plus h squared. Now that's all this quantity right here, and we still have minus 25 all over h. Now the 25s, they cancel, so we have h squared plus 10h over h. Now notice that we can factor an h out of the numerator, so we have an h times h plus 10 all over h. And so with the h's canceled out, we're left with h plus 10. And now we can plug 0 in for h, leaving 0 plus 10. So that is what our limit is equal to. Our limit is equal to 10. So we had to cancel out the h, but in order to do that, we had to expand out this 5 plus h quantity squared here. So our limit, as h approaches 0, of quantity 5 plus h squared minus 25 all over h, that's going to equal 10. Now the next few are not going to be polynomials, rather they're going to involve radicals. And so radicals are a little bit more difficult to deal with because you can't really factor them the way we do polynomials. But what we do is, when we have a radical involved, what we're going to do is we're going to multiply by the conjugate of this expression. Now the conjugate is you have two quantities you're either adding or subtracting. In this case, we have radical 3x plus 16 and then minus 4. We're going to multiply by the conjugate, which is radical 3x plus 16 plus 4. And we're going to multiply that on the top and on the bottom, so that we have the effect of multiplying by 1 if we multiply by the same thing on the top and on the bottom. So limit as x approaches 0. Now on the bottom, you don't want to expand this out. You want to leave it as x, which was already there, times 3x plus 16 plus 4. Now the top, you do want to expand. Now you want to treat this as two factors that you're multiplying. And so think of this radical 3x plus 16 as one term, minus 4 is another. So when I multiply these two together, the radical falls away. So we have 3x plus 16. So now I'm going to multiply this by 4. So plus 4 radical 3x plus 16, and then minus 4 times that, so minus 4 radical 3x plus 16, and then finally negative 4 times 4 is minus 16. So we have quite a large numerator, but what ends up happening is this term and this term are opposites, so they cancel, as well as the 16 and the negative 16. They're also opposites. So limit as x approaches 0. On the top, we're going to be left with 3x. And on the bottom, we have x, and then we have the quantity we multiplied in, 3x plus 16 plus 4. So now, the one thing we can cancel away is our x's. They can be gone. So we have 3 over radical 3x plus 16 plus 4. And now we can plug in 0 because we won't get a 0 on the top and we won't get a 0 on the bottom. We'll be left with 3 on top, and then radical, well, 3 times 0 is 0, so it's radical 16 plus 4. So that's 3 over 4 plus 4, which is 3/8. So that is what our limit is equal to. So looking down at number 9, this one gets people because there isn't a radical. And a lot of people think, well, we'll multiply by the conjugate. Actually, when you have fractions, you're not going to use conjugates. Instead, let's just magnifying glass the top and focus on that. We have 2 fractions, and we're subtracting them. What we want to do first is we want to combine this into a single expression. So I'm just going to move that over here. And so we have 1 over x plus 4 minus 1 over 4. So to get these 2 fractions to come together, we need to multiply the first fraction by 4 over 4, and the second fraction by x plus 4 over x plus 4. So doing that, we have 4 over 4x plus 16. The second one, we have minus x plus 4 over 4x plus 16. So since we have the same denominator, we can put them together. So we have 4 minus, now remember, we're subtracting this quantity, x plus 4, all over 4x plus 16. Now when we distribute this negative, it's going to be 4 minus x minus 4 over 4x plus 16. And the 4 and the minus 4 cancel, so we're left with negative x over 4x plus 16. Now, we can take this and put it back in the expression, because all we did right here was we just rewrote this, and instead of having 2 fractions, we have 1 fraction. So, limit as x approaches 0, so we have negative x over 4x plus 16 all over x. Now, a lot of people at this point have a hard time seeing what to do. So, what I often do is I often look at this and say, well, we're dividing by x. Another way of writing that is to say, well, instead of dividing by x, let's multiply by its reciprocal. Well, what's the reciprocal of x? 1 over x. Now we see that, hey, this x here and this x here, they can cancel out like we've canceled before. So when we do that, we're left with the limit as x approaches 0 of negative 1 over 4x plus 16. And now we can plug in 0 without having 0 over 0 as our result. If we plug in 0, we have negative 1 on the top. 4 times 0 when we plug in for x is 0, and that leaves 16 on the bottom. So when you have fractions, you want to get whichever it is, the numerator or the denominator, into a single expression, a single fraction. And then what will happen is something will cancel, which will allow you to find the limit. All right. Now, with number 10, this one is a little bit different, and you won't often see one like this, but it works on the same principle as number 8. You won't often see radicals in the denominator, but the idea still holds, is that we multiply by the conjugate. We multiply by h, radical h plus 5 plus radical 5, and we'll do that to the top as well. Radical h plus 5 plus radical 5. Now here we'll expand the bottom, but the top we won't, because what will happen is that h should be left to us to cancel. So we have limit as h approaches 0. On the top, we have h times the quantity, radical h plus 5 plus radical 5. Now on the bottom, these two multiply, so we have h plus 5. These two multiply, so we have plus radical 5 times radical h plus 5. Then we have minus radical 5 times radical h plus 5. And then finally, negative radical 5 times positive radical 5 is minus 5. So let's see. This term cancels with that, they're opposite. And this term cancels with that term, they're opposite. So on our next line, we still have the limit. We haven't plugged in 0 yet. And we always hold this until we can actually plug in 0. So on the top, it's h times radical h plus 5 plus radical 5. And on the bottom, the only thing that's left for us is h. So we can cancel that out. So our simplified expression is radical h plus 5 plus radical 5. So if we plug in 0, we get radical 5 plus radical 5, and that's just simply written as 2 radical 5 as our limit. So finally, our last one, this is another take on number 8, and it's almost identical except for the fact that there's no 3 here, it's just x. But still, we'll multiply by the conjugate. So the conjugate is x plus 16 plus radical 4. And then we multiply that on the top and on the bottom. Now we don't simplify, actually that's not a radical 4, it's just 4, my apologies. Sorry about that. Again, on the top, we don't multiply these together because the x will cancel. So we'll have, limit as x approaches 0, x times a quantity, square root of x plus 16 plus 4, no radical. So on the bottom, these we're going to multiply. So radical x plus 16 times radical x plus 16 is x plus 16. Radical x plus 16 plus 4, so we have plus 4. Radical x plus 16, negative 4 times radical x plus 16. And then finally, it's a 16 out of 6. And then plus 4 minus 4, we multiply, we have negative 16. So these two cancel, and these two cancel. So that leaves us with just x on the bottom, which happened just the same way as number 10 did when we had h on the top and on the bottom. So we have square root of x plus 16 plus 4 all over x. So there, our x's will cancel. So we have limit of x approaches 0. So our simplified expression is x plus 16 plus 4. So when we plug in 0, we have square root of 16 plus 4. So that's 4 plus 4. So our limit is equal to 8. Keep in mind that you keep the limit expression, keep the limit part as part of your expression until you actually plug in whatever it is you're plugging in. So you don't want to write that separately. And a lot of teachers are very particular about that to make sure that this is part of it. Because again, we're not finding what it is at 0, but what it is when it approaches 0. So, if you like this video, please give it a thumbs up. For more videos like this, click the subscribe button. If you have suggestions or problems like this that you want to see worked out, type a comment below. To support the channel, click the Patreon link to help keep this going. Thanks so much for watching. And remember, the only way to understand something is to do it.